Rationalizing a denominator. When we have a problem with radicals, you cannot leave that radical in the denominator. So the process of moving that radical out of the bottom of the fraction is called rationalizing. So let's start with, so I want to rationalize the denominator, get the radical out of the bottom. So to do that, do you guys remember what you do? Okay. We know that in a fraction, we can't change our problem, so if I'm going to do something on the bottom, we have to do it on the top as well. And what we did was multiply by that radical. Here's why. On the top, 1 times radical 3 is radical 3. Yesterday we talked about multiplying radicals and how if both things are underneath, you can multiply them together, so that gives us the square root of 9. But what is the square root of 9?
3.
So that turns into the square root of 3 over 3. So we move the radical out of the bottom. It's equivalent if you type 1 divided by radical 3 and radical 3 divided by 3 in your calculator, you get the same decimal. We're not changing it, we're just moving it, because it's not considered proper notation to leave it underneath. All right. If I gave you this, 5 divided by 4 radical 2. All right. So again, we can't leave the radical in the bottom. If I'm looking at this, the 4 isn't a problem though, just the square root of 2. So all I really need to do is multiply by that square root of 2. So if I do that on the top, 5 times the square root of 2 is just 5 radical 2. On the bottom, if you multiply the outside numbers, we just get a 4. Square root of 2 times 2 is 4. What is the square root of 4?
2.
So all that's really saying on the bottom is 4 times 2, which is 8. Can I reduce the 2 and the 8? No, because the 2 is under the radical and the 8 is not. Okay, now if it were like a 10 square root of 2 over 8, you could reduce the 10 and the 8. So far, so good? Let's do this one. So this is different for a couple reasons. First being, I have more than one radical on the bottom. Second issue, we have more than one term on the bottom. These things aren't just multiplied together like the last problem. When you have that addition or subtraction, there's more than one term. Do you guys remember what we did then?
Multiplied by the same thing, but plus 1.
Yeah, very good. Okay, so for a second, just put your pencils down and watch for a second. If you just multiplied by this exact thing, square root of 3 minus square root of 2. On the others, we were just multiplying by the radical that was on the bottom. If I did that, when you FOIL, you get the square root of 9 minus the square root of 6 minus the square root of 6 minus the square root of 4. Okay, square root of 9 is 3, but these radical 6's I can't reduce and they don't go away. So I didn't really get rid of my radical. So what we have to do is multiply by what's called the conjugate. Conjugate is the exact same thing, but you change the sign in the middle. So it was a minus, now I'm going to make it a plus. Here's why we like that. When I FOIL this time, if I do outside, I get the square root of 9 still. So first, outside is positive radical 6, inside is negative radical 6, last is negative radical 4. What happens to my radical 6's now? They cancel out, so that's why we need to change that sign. Okay, you can start writing now. So I just wanted to talk about why we're doing what we're doing. On the bottom we had to FOIL. On the top I'm just distributing my square root of 2, so we get the square root of 6 plus the square root of 4. We need to reduce everything we can. It's okay to leave radicals on top, just not on the bottom. So we have a square root of 6 plus, what is the square root of 4?
2.
Right, on the bottom, square root of 9 is 3. We already said positive square root of 6 and negative square root of 6 cancel. Minus the square root of 4 is 2. So on the bottom, 3 minus 2 is 1, and you could even drop that if you wanted.
On the FOIL part, we just have to do like the F and the L, right?
Yeah, if you realize that those inside terms are going to cancel, you don't have to show me that work. Can you guys try one of those? I want you guys to do this one for me. So, it's still 2 terms, but just 1 radical. If you only multiply by the square root of 2, on the bottom, 3 times the square root of 2 is just 3 square root of 2. Sorry, on the top. On the bottom, you have to distribute. What's 5 times the square root of 2? 5 radical 2. Minus the square root of 4. Is my radical disappearing? No, all I did was move it to the other term. So what do you have to multiply by?
5 plus.
Yep, the conjugate. 5 plus the square root of 2. You will have to do that anytime there's 2 terms on the bottom. So whether or not they both have radicals. So on the top, when I distribute, 3 times 5 is 15, plus 3 times the square root of 2. Right, the 3 is outside the radical, the 2 is underneath, so they just give me a 3 radical 2. You can't actually multiply them together. On the bottom, if you FOIL, you get 25. You might recognize that the outside and inside are going to drop, but if you didn't, you would have plus 5 radical 2 minus 5 radical 2 minus radical 4. So on the bottom I get 25 minus the square root of 4 is 2. So that's 15 plus 3 radical 2 over 23. So anytime the bottom is more than 1 term, you have to do the conjugate. What if, yesterday we had some, we didn't just do square roots, we had like cube roots and 4th roots. So let's take a look at some of those. If I just multiply this by a cube root of 3, is that going to help me here? At the bottom, I would get the cube root of 3 times 3 is just 9. Is 9 a perfect cube? No. What am I going to have to multiply this by so that I can cancel my radical? One way to think about it, a cube root means we need 3 of them before we make a perfect root, right? This is currently a 3 to the first. I have 1 3. I need 3 of them to make a group. So how many more do I need? 2 more. So you need the cube root of 3 squared.
Or could you just put 9?
Yeah, you can put 9. Okay, so on the top I have a 4 cube root of 3 squared, which is 9. On the bottom you could write 3 to the 3rd power or 27, either way. So the cube root of 3 to the 3rd or the cube root of 27 is 3. So I get 4 cube root of 9 over 3. Give you the 4th root of 3/5. If you have a fraction under a radical, you could split it up and do the top and the bottom separately. Okay. If I want to get this radical off the bottom, what will I have to multiply by? The 4th root of? I currently have 1 5. In order for this radical to disappear, I need a group of 4, so I need 3 more. So you can write 5 to the 3rd, or you can do 125, they're equivalent. So on the top, use your calculator if you need to, 3 times 5 to the 3rd.
317.
On the bottom, you have the 4th root of 5 to the 4th, or if you multiply that out, that's the 4th root of 625, which is just a 5. Questions?
I just did the 4th root under 625 is 4th square root.
Uh-huh.
I didn't get 5. Did you get like 5?
So a little bit different. We have 2 fractions, 2 separate fractions. First of all, we know if we want to add or subtract fractions, what do we need? Common denominator. We also know we can't leave the radical off on the bottom. And looking at these radicals, can they be reduced at all? They're not perfect squares, but could you pull any perfect squares out? Yes. So there's a lot of stuff that we can do here. It means there's a lot of different starting points. So let's begin with breaking down these radicals. That way we're dealing with as small of numbers as possible. How would we break down the square root of 12?
43.
Okay, so that gives me a 2 over, the square root of 4 is 2, radical 3. What about 27? So that gives me 1 over square root of 9 is 3, radical Okay, do you notice anything about these fractions?
Same.
Okay, they both have the radical 3 in the bottom. The first one, could I reduce those 2's? Yeah, they're both outside the radical. You don't necessarily have to do it here, but we need to at some point, so we might as well. Okay, so we have to do 2 things. We have to get the radical off the bottom, and we have to get a common denominator to put these things together, right? Let's do the common denominator first.
Multiply the first group by 3 radical 3 and multiply the second group by just radical 3.
Okay, that would work. If you just take them times each other. We can also maybe even make life a little bit easier, because if we look, they both already have the radical 3 part. So the only thing the first one really needs is a 3. So we could just multiply by 3. You'll get to the same point if you just multiply them by each other. We'll just have to reduce later on. So that would give me since the denominators are the same, now I can subtract the tops. 3 minus 1 is 2 over 3 radical 3. So now, if I want to get the radical off the bottom, what do we multiply by? The square root of 3, right? So I get 2 radical 3 over 3 radical 9. Square root of 9 is 3, so that means 3 times 3, which is 9. So I like that problem because it kind of tested a lot of stuff we've done. The common denominator that we've done, the breaking down radicals that we've done, and the rationalizing. Is that okay? Let's do one more. Sorry, I know that one's a little bit blurry. I cut it and pasting. So that's the cube root of 8m squared into the third times the cube root of 2m squared over the cube root of 32m to the fourth into the third. What do you think we should do first?
We can take the m's out of the radicals.
Okay.
And we can reduce the 32 and like the big numbers.
Uh-huh. So there's a lot of places we can reduce radicals. If the radicals on top are multiplied together, could we go ahead and multiply those and combine them into one radical on the top? Yep. We have to get the radical off the bottom. So we have a lot of stuff to do. We just have to pick a starting point. Let's start with clean it up as much as we can. If I have these radicals multiplied, let's go ahead and do that. So I'm not trying to reduce 3 different radicals. We'll combine them into as few as we can. So since these are all under the radical, we can multiply them. So 8 times 2 is 16. M squared times m squared is m to the fourth, and then n to the third. All right. Now I have a suggestion. I put this problem on here intentionally. Both the top and bottom are under a radical. When things are both under a radical, we can multiply them, but the same is true with the dividing. Since both of these are under a radical, I could reduce. The radical stays, but the other stuff can cancel. So if I'm looking at 16 and 32, what could I do to those? Divide them both by 16, so that would give me a 2 on the bottom. Now that 2 is still under my cube root. All right, what happens to my m to the fourth? Yeah, and you get m to the 0, which is just 1. Those m's just canceled out. What happens to my n cubes?
Take on 2.
So all I have now, everything on top canceled out, so I just have 1 over the cube root of 2. So that cleaned up a lot. If I want to get that radical off the bottom, what do I need to multiply by?
Times cube root of 2 squared.
So on the top, I have cube root of 2 squared is 4. On the bottom, I have the cube root of 2 to the 3rd, or you could make that an 8. So you get the cube root of 4 over 2. So if you have radicals on top and bottom, you can reduce things. You guys have any questions for me there? Alright. We have quite a bit of time left. I wanted to let you guys finish your homework. I'm done teaching. So that handout is due tomorrow. You have the rest of the hour to finish.